Thank you very much. It's a great honor for me to speak to you today. Uh, First, I will apologize myself because my English level is not so good. And also, normally I'm traveled this last year. I traveled a lot. Well, I traveled a little bit to foreign English speaking countries. So I'm used to use my English, but this last year I didn't travel, as I think a lot of yours, and I didn't speak a lot of English this last year, so my it's a little bit difficult for me now. It's not fluent as some other times, so I will try to be to be the more precise as I can. So first, I'm gonna introduce myself and my university and where I'm working, which department. And as explained by, I didn't remember the name, I will talk about is more about sharing my experience of teaching. First, so and also during this COVID period, it was a little bit difficult. So I will ask you, but it will be very focused on my field. And my field is computer science, embedded systems. So I'm sorry for the people who are really not in this field. So perhaps it will be less interesting for them, but it's my share of my experience. So, so the summary of my presentation is about the evolution of my teaching method during this last 20 years. And I will focus on the methods I have developed since the start of the pandemic, a little bit also. And also, I'm apologize because I didn't have a lot of time for prepare this presentation. So I don't have a lot of slides, but I'm gonna show you the platforms that I used and how I use them. And also, it will be nice to ask me some questions during the presentation through the chat, or you can take the speak and ask me some question also during my presentation. I prefer some interactive than waiting at the end for the questions, but you are free to interrupt me and to ask me some question during my presentation. So I will focus on this, on the methods that I developed since the start of the pandemic, the COVID pandemic, and also I will focus, share my experience in teaching in several matters like IoT, VHDL, microcontroller, embedded system, who are my fields of teach. So my principal courses. So first, I will present my university. So my university is called now Sorbonne University, but before it was calling UPMC, like Université Pierre et Marie Curie. It was created by the name of Pierre Marie Curie is in French very famous. They do a lot of research about atomic energy, and but since 2018, there was a merge of two universities. It was UPMC and Paris 2, Université Paris Sorbonne. And these two universities create a big university who's called Sorbonne University. And we have in this university 3 faculties, 1 faculty of arts and humanities, 1 faculty of medicine, and 1 faculty of science and engineering. And I'm working in the faculty of science and engineering. And it's in total around 50,000 students and more than around 20,000, 20,000 employees. I don't know exactly how many teachers and extra, but it's a big university today, one of the biggest in France, and from the merge of these two entities. Okay, yes. It was a little bit error. Around 50,000 students. We have 5,000 academic faculty staff. That is only for No, sorry, that is for the total. We have a good rankings, some good rankings in the international ranking. Here in the Shanghai rankings, we are last year 44, that's not up to date. But here you can see the ranking of our university in different rank international rankings. Okay. No, sorry. Yes, we have three faculties: Faculty of Art and Humanities, Faculty of Medicine, Faculty of Science and Engineering. And I'm working in the Faculty of Science and Engineering. We have around 20,000 students, and there are 6 academic and research departments that we call UFR in French. And that's in biology, chemistry, engineering, so mathematics, physics, earth science, environment, and biodiversity. And also, there are some institutes. There is an engineering school, Polytech Sorbonne, and there are 2 institutes, Paris Astrophysics Institute and Henri Poincaré Institute. And here in the engineering, there's mechanical, software, computer science, electric engineering, robotics, a lot of different engineering. That is a big UFR. And I'm working in the Polytech Sorbonne Engineering School. I don't know if you know the French system, but in France, we have a university, but we have also engineering schools. It's a little bit special. They are normally outside the university, but in my case, it's an engineering school inside the university, and that is a little bit special for France. Okay, so now I make a little presentation of Polytech Sorbonne Engineering School. So we have around 1,000 students. It's a 5-year studies. Well, no, it's more 3-year studies. It's from year 2, license 3, sorry, to master 2. It's 3 years. And but we have also an integrated preparation here. It's when we give the diploma of 2 years ago of all the how do you say it, the graded students. Okay, we have 8 specialties in this engineering school: agri-food, applied mathematics and computer science, earth science, electronic and computer science for embedded system, electronic and computer science for industrial application, materials, mechanical engineering, and robotics. So, and I'm working in the electronics and computer science for embedded system, and I head manager of this department. So my job at Polytech Sorbonne is to, so here you can see, it's a department with 120 students, around 120 students. It's a 3-year study. I'm managing an educational team of 25 teachers, around 25, I think a little bit more. And we have during these studies also 3 training periods, in total 36 weeks. And I am what we can see in English, senior lecturer or lecturer. Yes, I don't do research. I only give courses. In French, we call it professeur agrégé. It's a little bit special. I didn't do research, and I do a lot of course. I do each year around 800 hours of course in this kind of field, in chip design, so VHDL, so hardware description language, in co-design hard soft, in system on chip, FPGA, in this field, in embedded systems, in embedded C, microcontrollers, real-time operating system. Also, since it's 5 years, I developed some courses in Internet of Things. So with the LP1 technologies, Bluetooth, energy, Bluetooth technology, Wi-Fi, low power design, and also since 2 years now, artificial intelligence. I do a little course about artificial intelligence and more focus on embedded systems. And also I do a lot of projects and I follow a lot of projects in embedded system, in connected object, and also some industrial projects that we do with some industries. They give projects that our students are developing during their studies. Okay, so outside Polytech, Sorbonne, I do a lot of also courses in an international field. I do some, since 3 or 4 years, I go to China at Xijian University in Xi'an. It's it's a city not so well known as Beijing, Beijing or Canton, Guangzhou, but it's one of the oldest city of China. And there I have a program. We have a program. We receive some students of this university, and we go there to give in course. And I give course about microprocessor systems, about ARM7. I do also some course about digital electronics, VHDL. I did also some real-time operating system for an international week. And I do some course in IoT and artificial intelligence for graduate students, also 1 year. Also, since 2009, I'm also technical consultant in the industry. I do some course for Thales about embedded calculators for aircraft, and also working a little bit in some startups, like, but they are not well known for you. I think Smart Impulse, WiseByte, DidaLab. I do since 2009. I also work a little bit in as a consultant in the industry. I also give since 5 years some courses in private engineering schools in Paris. So they are from your side perhaps not well known, but there are EPITA is a big engineering school, and CEA and ISEP. I give some courses there about since a couple, 5 years. So that was my presentation. And I see that you're not all working in the field of computer science or electronic engineering, but I can see that a lot of you are working in this field, because the next slide will be focused on my teaching experience, and I will show you some of my courses and the materials I use for these courses. First, I will make a focus on the evolution of my teaching experience. I begin teach in 2003, exactly, but I also teach a little bit during my studies. And in this time, the organization of a standard 30-hour course, it was a lot of lecture that we call in French cours magistraux, some tutorials that we call in French travaux dirigés, that is more exercises, and some labs, so that we call in French travaux pratiques. And I was, during this period, I was a little bit disappointed, because most of the time during the lectures, the students didn't remember that what I'm talking about, and I have a lot of time to repeat all the things during the labs and during the tutorials. So the conclusion of this organization of my courses was not so good results. The knowledge of the students at the end of the course was poor. I was thinking the most of the time I was in lecture, I was speaking, but the students didn't remember a lot of what I was talking. And I saw that the most of the knowledge was acquired during the labs. So I changed. So here is very short explanation, but I changed a lot of my courses during the next 10 years. So I change a lot of my course organization, and I do a less lecture, so only between 6 or 8 hours of lecture. And most of the time, it was short periods of lecture of half an hour or 1 hour, not more. And I do a lot of labs, of tutorials, and I try to do a project in each of my courses. So I do more and more projects because I was seeing that the knowledge and the skills, also the skills, because it's not only knowledge. And today we're speaking a lot about skills acquisition was acquired during the project. And when you have to think by yourself about solutions, because when you are doing following a lecture, following a course, the students are very passive and they remember only 10 or 5% what you are saying. And when you are doing a lab, they following a tutorial, of we can call it, I don't know if you call it tutorials or labs. They are following a subject, so it's more, they are more active, but they don't ask them a lot of questions about how to find a solution, how to develop knowledge, and how to acquire real skills. And during a project, so they are more active, they are really thinking about solutions, they are making mistakes. They are, so I do a lot of project-based learning, we call it like this. And a lot of my colleagues also in other fields, in mathematics, physics, are developed what we can call a problem-based learning. We make a lot of, we make some we learn some methods of these methods with we learn some methods of this kind of learning with University of Louvain. I don't know if you heard about this university in Belgium. It's a university. We are doing only project-based learning and problem-based learning, because there were things like me that course was not so efficient. So a lot of my colleagues and me too, we changed our methods to do a more and more project during our courses. So that is a little bit focus on the evolution of my course organization during my 20 years experience. I do more and more projects. So teaching with the COVID-19 pandemic. So I make only one slide. I'm sorry I didn't, because I don't really know how to express it. But we make a massive use of Moodle. I don't know if you know Moodle.
Yes.
Yes.
All
Perhaps.
universities here in Palestine use Moodle.
Okay. It's a very, so we use it before the pandemic, but now since the pandemic, we use it a lot to share the course materials, to share the lecture videos. So I make a lot of videos of my courses. So because I do in live streaming, because the students prefer to have live teaching, but I make also some videos of my lectures, so they can go to see back to see some part of the course. I use tools because when we are doing some, by my experience, when we are doing some online courses, the students need to be interactive, because listening all the time to someone speaking in a screen is not so interesting. So they ask a lot of interactive, and I use tools. It's called WooClap. I don't know if you know it or if you use it, but it's a very good tools. I can show you perhaps shortly. I'm going to show you rapidly this tool. So here is a Moodle. and I'm gonna, sorry. Tac. Oh, sorry. I show you here, for example, I think I use it here. So WooClap is a tool. It's introduced in it. You can use it. Oh, sorry. So you can. So it looks like this. So you have a link here. The students gone on this link, and they can. You can ask some questions. Like here, it's a question, and they can respond to the question. And then also we can see who did the good answer. We did here. We can see that 30 students give the good answer, and 3 students didn't give the good answer. And you can see it interactive. So you can ask a lot of questions. You can make some easy questions, and then the student can answer, and they can see. And you can see also if they retain the most important topics of the course. And also the students like to have some more interactive part of the course in place to listening during 1 hour, someone speaking. So I know that with the chat, you can also have some interaction, but most of the time the students don't ask a lot of questions. I don't know what is your experience, but in my experience, they did sometimes 1 or 2 students are asking some question, but to do some interactive questions. So to when you have a course and you stop and you give some questions, like I try to do it for more and more of my courses. And here is the interface. So you can easily create a question here, give some response, and then launch ask this question on live. So I don't know if you are using this kind of tool, but I have a good experience with this tool in Moodle.
Is it like Mentimeter?
Perhaps there are other tools. I think there's a lot of tools, but I'm not a specialist of all the tools, but perhaps there's another with this name. So I use WooClap to make some interactive question. Also, I used another tool is called Code Runner. Code Runner, so that was very that's auto code check. So it's a tool. You can use it in a software language for C language, Java, Python, but also I make accommodation to use it also with VHDL, because VHDL, hardware description language. So the students can deposit their code, and the platform will execute it and see if the code is correct, and then say to the students, the code is correct or is not correct, and here are the errors. So that is useful first for the people who don't have a lot of software tools, but but also to see, to verify for me that the students are doing the exercise and that they do it correctly. Also, for the evaluation, I use a lot the test module of Moodle. So most of my tests now, I do it, I think perhaps you also, most of my evaluation, I do it on Moodle today. So, and I have, sorry, here, for example, no, I think that you're also using this kind of, if you have Moodle, this kind of tools, but it's very useful. So you can ask some questions. So what I do to have not because the problem with online evaluation is that the student gonna I don't copy, or but the solution is to ask a lot of questions in a short time that I found, and also to share or to not give the same question to each student. So it takes some time to prepare the evaluation, but at the end, the evaluation, you can make more evaluations. So, and also the correction time is very short. That is the good side of this work, of this kind of tools. But it takes a lot of time to prepare an evaluation. But one time you prepare, you have it. So the correction time is shorter. So I do a lot of evaluation during this pandemic with this kind of most of my evaluation. So, and perhaps so also you can create easily some question, give some answers, give some point to each answer. So here you can ask some MCQ questions. So with right or false, but like here's more right or false question. That is easy to make, but also you can create some questions when you have to give a short response, like here. Okay, so I put some different response that you can give and see if they have made the good response. You can the response can be also a number, like here. It's not so as good as a normal evaluation, but during the pandemic, it was a good solution I found to make some evaluation online. And also, I use, that it was also very useful, the deposit. So here I have a microcontroller course for each lab. For each lab, I create a deposit where they can give back the code and the explanation about them work, the report of the work. So here you can see that is one of my Moodle course organizations. So I give here the pedagogical sequence, and then I put for each chapter the course materials and also the video of this course. I give for some, here's tutorials, some exercises. So I will explain it later. So, and what we are doing during the pandemic is to follow them on for the courses. So I use massively Zoom, and I think like you. And also we use a lot of Discord, because I don't know if you know, Discord is a free tool. You can use it freely, and it's very common because the students use this tool a lot together. So they are they use this tool very easily. And for following the labs and the project and the tutorials, we use more Discord. And for the lecture, I use Zoom, because the quality of the bandwidth, etc., Zoom was better than Discord. So perhaps I show you also Discord. I don't know if you, no, it's not open. Oh, sorry. Okay, Discord is I think at the beginning it was more a gamer platform for gaming, but we use it a lot in education. So it's a platform, so they create some servers here, and we have for each year and for each module a channel. For example, for my microcontroller course, we have a channel here, And so we can chat interactively, but we can also have some video channels like here. You can share your screen. They can share their screen also. So we used a lot of Discord last year for the labs and for the projects and also for the tutorials. Some of my colleagues using also tools is called Big Blue Button. I don't know if you heard about it.
Somehow, in some of universities, yes, some is not. But each one has model can use.
Yeah.
Can use
That
this.
is some. I didn't use it, so because I didn't take the time to. But it seems to be a good tool also. What? Yeah, at the beginning I didn't use it because there was some bandwidth or some problems to connect together. Some students were disconnected. So they use Big Blue Button and also another tool, but I don't use it also.
It look like Zoom. Like Zoom, they record. Also they can record lectures. I evaluate university who use this Big Blue Button.
Yeah,
it is very close to Zoom and to go meetings.
Yeah, but you can. What's the difference? That you can make some rooms, and you can have some blackboard, and you can. But I think in Zoom you can do it also today. Yeah, but I don't use it.
Yes.
These tools of Zoom, but you can make groups in Big Blue Button. You can meet several groups, and then they can work together. Yeah, it's integrated in Moodle. So, and Panopto to make some video. I use it also, but just one time. For the video, I'm more using YouTube because it's. I found it easier to make some video, to put it on YouTube, and share with the students. So that is most of the tools I used. Now I will explain a little bit more focus on 5 courses I did during the pandemic. So also about the organization of this course. So what I was doing, so I do a lot of computer science courses and a lot of engineering, electric engineering and embedded systems. So here, for this VHDL course, hardware description language is 60 hours. I have 11 short lectures of 30 to 45 minutes, followed by 11 exercises. And these exercises are using a simulator. So it's here, the software tools that I use was Model Sim or GHDL with GTK waves that are open source. And Model Sim is a free tool. So during this course, they have to download this software to install on their computer, and then they can do the exercise at their side. And so I show you rapidly Model Sim, but it's more for that tool like this, and you can do some simulation of some logic design. Digital logic design, and you can see some results. And these tools is very well known in the industry. You can have it, you can have some free version if you take the Model Sim Altera tools. So if you want to have more precision about this kind of tool. So, and for this course, I use a lot of simulation normally, and also we use a board is DE10. So yeah, I will give some answer to the question. STM32 microcontroller, yes. To answer to Khaled, I will show you later. But for this course, I was doing a lot of simulation during the exercises. And I have 2 labs about BCD counter and VGA interface. This one was possible only on boards. So it was difficult to do it. Normally, I do it it was difficult to do in, I don't know how to say it, online courses. What in French we say présentiel, distanciel. How do you say it in English? I'm sorry, I don't find the words.
Synchronize and asynchronise.
No more presence and no presence. Distance. So distant teaching and presence in the lab. I was more talking about this because these 2 labs, they need some materials. But what I did with some students, I give a board to each student so he can use it at home. I'm using this kind of board. I present it also a little bit. Is a very good board. You can do a lot of things with this board, and also it's not so expensive. It's cost $60, and sometimes you have academic you have an academic price. And this is a board, FPGA board, where you can do a lot of labs, and they can do it at home. So for some of my courses, I give the board to one board to each student, so he can do the lab at home. That is more focused on digital electronics. So you have a lot of switches, LEDs, 7-segment display, and you can do some exercises, some labs with this kind of board. You can also connect some outside boards. So that is a very useful materials to do my courses. And you have also some examples. There are also some labs given by Terasic, etc. Sorry. So, and I use Model Sim for simulation, and I use Quartus 2. It's an Intel Antera tool to do this kind of course. Also, for these schools, I do 2 kind of projects. As I say before, I do a lot of projects at the end of my courses. And I have 2 kind of project. I have one project the goal is to describe the architecture of a 32-bit processor based on the instruction set of the famous ARM7 TDMI core. I can do it with only simulation, so that is useful for distance course, online courses, when you cannot go to use the materials. Or we can also we can also synthesize and test it on this board. I have also another project is describing an UART core and communicating with a PC through a serial link. So that is, but for this one, normally we need a board and a PC to communicate. Okay. Then another course. Here I focus a little bit on my course. Sorry for the people who are not in this field. Okay. So the co-design ArtSoft is the objective of this course is design a complete system around a soft core. A soft core is a processor described in VHDL, in hardware description language. We have in this course 3 short lecture of 1 hour plus 3 lab. It's 3 kind of tutorials who explain how to use the tools. The first course plus the lab is create an entire system on chip around the NIOS-2 soft core. So that is a famous soft core given for free by Intel Altera. Then I have a second course plus the lab is adding a custom peripheral to this system on chip. And then I have a third course and lab is working with Linux on the Cortex A9 to doing some simple driver with the mmap method. And then I have a little project who consists to add some other custom peripherals and to do a 2D radar with ultrasonic telemeter and servo motor. I hope that you can understand my English accent. So for this course, I use a little bit the same tools at the VHDR course. Is the tools from Quartus. They are free. Well, you can have there are one part of these tools are free, the light edition, because when you are using this tool, you have the standard and the pro. There you need the license, and the light one is free. So the student can install on their own laptop, and so you can do also some distance course.
Prof Yann, can I ask you to copy paste and in chat these two links?
Sorry?
Copy and paste in chat.
Okay, okay. But I can, at the end, I can give you my presentation also. But sorry, I will copy and so here are the tools I use, and here is a famous board. So this board, I will make some explanation because it's very useful. It's used in a lot of American university. It's also a board with, you can do a lot of labs projects. So it's a very complete board because you can do some computer science, you can do some Linux, embedded Linux, you can do digital electronics project or labs. So, and it's not so expensive. It's $220. Well, perhaps it's, I don't know what are your budget, but and you can do, and it's given with a lot of resources, with some demos, and there are also a good user manual. And also you can find a lot of labs given in the American university on this, or some projects. It's used when, if you're searching on the internet, you can find some teaching materials about this board. Okay. Then I do some Internet of Things courses that since 5 years, quietly. And I do teach about Wi-Fi, about Bluetooth, about LP1 technologies. So LP1 is LoRa and Sigfox. I don't know, it's quite new technologies, but very used in the industry. I do some lab with Sigfox modules. I do also some MQTT, REST, and CoAP protocols. I explain these different protocols for the IoT. And I have two little projects. One project is sending data from a device to a cloud with REST and MQTT. And I have a second project, is low power device sending data with Sigfox. So we create a sorry, there's an error here. Sorry. Device sending data with Sigfox. Okay. And here, the software tools, I'm using Arduino most of the time, UbiDots and IBM Cloud Lite. All these are UbiDots, Arduino, IBM Cloud Lite are free. You can use it freely. And so it would be nice to explain a little bit more, but I see the time is going fast. Huh? And the hardware, I'm using ESP32 hardware. It's a very also useful board because it costs only 5 or 10 euros and you can do a lot of labs in the IoT field. So, sorry. You can search on internet. ESP32 is a board that's with, I'm gonna look on Wikipedia, is a board, no, not this one, but well, it didn't matter. It's a board made by a company called Espressif, and there's a architecture, there's a Wi-Fi, Bluetooth, and it costs a module, ESP32 module is cost like you can find for 3-5 euros if you buy it in China, but I think you can buy it for very cheap. It's very cheap board and very useful to do a lot of labs in the IoT field. So I put it here, ESP32, or another board is called ESP3266. It was the previous version with only Wi-Fi. And there's a lot of help. And so, and also I was supposed to present you also do-it-yourself hardware, because, for example, you can find a lot of examples on the site. I don't know if you know it. I use it a lot with my students, Hackster. Hackster.io. It's a maker site where you have a lot of projects made by people with do-it-yourself hardware. And you can find some very good projects where the people explain all the project, the electronics, the code, etc. So there can be some ideas for lab, for project, for yourself project, and also to learn some new things. Okay, I share also with you. And also this last year, this last year, I asked my students, not MCV2, it's a lit. Okay. So there are some questions. I will respond to this question perhaps now, but what is the difference between this device with Raspberry Pi and not MCV2? Is this one also interesting? So I'm going to show you. I have the little presentation and I want to present you. Sorry, it's not here. It's here. I'm gonna do it shortly. I'm gonna send you also this presentation. Do-it-yourself hardware. So I use it more and more in my courses because it's very cheap, and also it's very nice for the student to use it. So I think you all know the Arduino platform is born in 2005. It combines some software, hardware. It's great for prototyping. It was made by origin for artists. It's from Italian origin. So you have a lot of different hardware, Arduino hardware boards also, and also software. It's open source, open hardware, open software. You have a standard form factor. It's really easy to program. Also, that is very nice. There are a lot of different boards, but there's also some shields that you can add, and you can make a prototype, rapidly a prototype. There's a software programming that is free also. You have many libraries. It's based on Java, but you write in a kind of C, C++, etc. So that is Arduino. Then you have Raspberry Pi. So the thing is that an Arduino board is cost between 10, 20 euros. A Raspberry Pi is a little bit more expensive, is more about 35 euros. And here it's a big system. You have a Linux, you have ARM-based, you have some HDMI, you have some USB, GPIO, audio, etc. So you can do a lot of fun projects with a Raspberry Pi. As I think you use it already in your courses. I use it also. You can program in Python, in Java, in C++. You have a lot of libraries for hardware. I gone a little bit fast because the time is running. you have some several interfaces to do SPI, UART, I2C, etc. But the problem, you have no ADC, and you have, since Raspberry Pi 3, Wi-Fi and BLE. So, and that's Raspberry Pi Arduino, they are famous, but here ESP8266 chip is a very simple chip. It's more microcontroller focused, so, okay? And it consumes less power, and it's more easy to use to begin a program. So, and its cost, this board costs only €2. And you can buy it for very cheap. So this one is very simple, but you have the Node MCU. This call is the cost is around €8. It's quite the same. And here you have a board with several input output. You can program it with C++ with Arduino. You have a Wi-Fi and one ADC. And then since 2016, you have ESP32 with the Node MCU version 2, which talking your colleagues before. And that is a very board, very common to do some IoT projects or labs. I'm using a lot in my course, also in the RTOS course. So that was a brief about this kind of board, because it's very cheap. You can give a board to each student easily, and they can do a lot of projects easily with this kind of boards. So that was a little bit focus on this side. So the difference with the Raspberry Pi is that it's cheaper, it consumes less energy, and it's more easy to program. You don't have a Linux system. You can use Arduino IDE, and that is the difference with the Raspberry Pi. Okay, for my MCU course, what I'm doing also is that I share a box, a NUM box, with my students. Okay, and in this box we can find MCU board. I'm using, for the moment, I use the Arc Pro LPC70. It's a little bit looking like STM32. That was another question, but it's not quite the same. But it's a NXP board, and I share LCD screen, temperature and sense sensor, push button, ultrasound telemeter, potentiometer, sound buzzer, loudspeaker. I give a board to each student so he can do the lab at home. And that I'm using this kind of tools to do the course during the COVID period. And the tools I'm using is these two tools. I don't know if you know it. Sorry. I share the links as asked. So Kale is more conventional IDE, and Embed is what is very common is that it's an online compiler. So you don't have to install nothing to install on your computer. You can use it online. And that is very easy to use for the students, so they don't have to install anything. Oh, sorry, it doesn't work now. No, I need to use another one. So, but perhaps I need to use Safari. Okay, here you can see the embed compiler. So it's a very easy manner to program microcontrollers. You have here at the left side, the different projects. You can edit the code online. Okay, and then you can compile here, and you can very easily program a chip, a board, you just, when you plug a board, you see it like a USB stick, and you can put your code on the board. So I use a lot of these libraries and this because so the student don't have to install anything. They just need a browser. It's free also, and also it's a high level of programming. Okay. I'm a little bit out of time, sorry. So my pedagogical sequence for the MCU course is an introduction. I make some course about GPIO and Pincel, some exercise on simulator, then external interrupt, then exercise on board, serial interfaces, I2C, SPI, serial, and then I do a lab on board, which is to write on the LCD, RGB. I talk about the timer, I do an exercise on a simulator, and then I have a lab about an ultrasonic range finder. Then I talk about the analog interface, and I have a lab about an audiometer. And then I do a course about embed OS RTOS, so the platform and also the real-time operating system of this platform. And I do a lab about motor control. And then I have a project is to embed an FFT on a microcontroller. So that's very interesting because they have to see some algorithm that fit on a microcontroller and can be running in real time. And also I do a line finder robot, and I do a challenge. So the student likes also this kind of projects. So I finished, I'm sorry, a little bit late, but I want to show you a last video because I do a lot of projects also. And one of my most important projects is to develop a complete embedded systems with sensor, with embedded signal processing with an MCU, do some wireless communication, power efficient and autonomous with a battery and solar panel, and also with a cloud dashboard to see the result see the result of the monitoring. The objective of this project is to do a beehive monitoring. And in this project, we involve also some beekeepers. And it's a project of participative research. Is that in the project, we have some students, beekeepers and teachers. And I will finish to show you a video. You can have it on this link, but I'm going to show you the original version. Sorry. Well, I'm going to show you the online. So it's one of my projects. So it's in French, so I'm going to try to translate it. So we were working with students on real beehives.
Bonjour, donc je me présente, je m'appelle Yann 12. Je suis professeur à Polytech Sorbonne.
Here I introduce myself.
Spécialité électronique informatique pour les systèmes
embarqués. That is our project room.
Dans le cadre des projets avec nos étudiants, cette année, on a mis en place un projet qui s'appelle OpenRush.
So the name of the project was Open Beehive.
Et de répondre à tous les problèmes qu'il peut y avoir autour des abeilles aujourd'hui.
And it was focused on the bee problems.
Oui, effectivement. Donc, moi, je
here, there's a beekeeper who was explaining the different problems that he has in his work.
Ça, c'est quelque chose qui est perturbant pour la
For example,
l'autre problématique, c'est par exemple aussi
I don't know if you have this problem in Palestine, but there's varroa. I don't know the English name.
Non seulement l'état de la colonie, mais aussi, bien entendu,
la récolte
it's a parasite here
qui en
of
découle.
bees.
Puis ensuite, le frelon asiatique.
Then you have
qui
the
était importé
Asiatic
maintenant il y a une
frelons.
dizaine
I don't
d'années,
know
dans un
the
endroit
English
qui
name,
est
but
à
that
Agen,
is also
qui
very
détruit et qui va
a
donc
big problem in
stresser
France
nos
today
abeilles,
with
qui vont
the
les
for the
perturber dans la récolte
beekeepers.
ouvrière. Et il y a un gros business sur le vol
And
des,
also
le vol des ruches.
there are some
Une
people
ruche
we
comme
are
celle-ci,
stalling
avec
some
une colonie qui
beehives
tourne bien,
because the
c'est
beehives
de
is
l'ordre de
costing
300,
between
350
300 and
Toutes ces
350
problématiques,
euros.
on va chercher des solutions et
So
tout
we're
gérer des
finding some
informations qui vont
solution
permettre de générer des alarmes
to
pour les apiculteurs,
to
SMS,
monitor
email.
the beehive.
Avec les informations qu'on a eues,
So they
qu'on a
put
reçues des
some
apiculteurs,
sensors on the
on a
beehive
orienté nos objectifs
and
la première phase du projet,
to
qui
acquire
était
the
celle de
temperature
recherche, en fait.
inside the beehive,
Du coup, on
the
s'est
weight of
orienté
the
vers un
beehive,
capteur de poids, un capteur solaire pour la
and
luminosité,
also to be
savoir
autonomous
son
in
impact.
energy,
Et après, des
also
capteurs
to acquire
de
the
température
temperature
et d'humidité,
and the
aussi
humidity.
bien intérieur qu'extérieur, avec aussi un micro, parce qu'on s'est
We
renseigné
also
et
monitor
on
the
a
sound
appris
of the
qu'il pouvait y avoir une
bees.
corrélation entre le son produit par les abeilles et leur comportement.
Donc tout ça, on va commencer à le faire sur une carte.
We
qu'on appelle une
first
carte,
make a
d'APTEC
prototype
ou,
like
carte de
this
prototypage.
to test
Donc,
all
c'est
the
la première
sensors
version,
and
donc ils
all
vont tester tous les
the
capteurs,
communication
les utilisateurs,
modules,
toutes les communications. Et une fois qu'ils ont validé tout ça,
do
ils
the
vont
code,
créer une carte
and
électronique.
then they
comme
need
celle-ci,
they have to make a
plus
PCB,
robuste. Hein, donc, ce qu'on appelle
printed
un
circuit
PCB,
board.
printed,
We have the
circuit board.
tools to create them at school. And then they have also to do the
et qui
packaging.
va être mis dans un boîtier qui va être mis sous la ruche.
So they
D'accord, donc un
package
boîtier
all
plus
the
ou moins grand,
battery,
et tous les
all
capteurs
the
vont aller
electronic
dans la
boards,
ruche, donc par les différentes
and all the
entrées,
sensors
ou à
are on
l'extérieur
the
pour les
beehive.
qui sont à récolter à l'extérieur. Et toutes ces informations sont remontées en fait grâce à un module de communication.
And
Then,
then
la technologie
all the data, the sensor data
pour
are
les objets connectés très basse
are
consommation, très longue distance. Et on envoie un
monitor
message
on
toutes les
some
10 minutes
platform.
pendant quelques secondes pour remonter les données des capteurs. C'est quelque chose
Here
qui
we have the
dérange beaucoup moins les abeilles. Derrière, en fait, il y a un travail aussi qui est fait sur l'analyse de toutes ces données et remonter des alertes pertinentes. Et donc là, il y a eu des tests qui ont été faits.
and we made some
Et les
tests on
étudiants sont
the
venus sur le
real
rucher.
real
Ils ont
beehives.
déployé ces
We
ces
do
capteurs
some
sur
on the
des
field.
ruches, sur les vraies ruches avec des vraies abeilles pour tester en fait la
We test
faisabilité. Et
the
par exemple, un
robustness, the
truc intéressant,
feasibility of the
c'est que
project.
ce capteur, qui est un capteur
And
de
that was very
température
nice for the
limitée,
students
fourni
to
quand même
use the
pas mal
project
de-
in a real
d'avantages. Ben, on a eu beaucoup de mal à le
in
mettre
a
dans la
real
ruche.
application
Donc, on
with
s'est rendu compte
real
qu'il est très
people's
bien,
real
il est,
real
il est très beau,
and here also
mais
we
il est
can
pas
see
forcément
that some
adapté
sensor
aux besoins
doesn't
d'apiculteurs.
fit.
Et c'est là en fait où c'est la genèse un peu de ce projet. C'est un projet de recherche participative où il y a les apiculteurs, donc
So
Jackie,
it's
il y en
a
a d'autres,
participative research
sont là.
project with
il y a les étudiants,
beekeepers,
les
students,
enseignants, et on est dans une
teachers.
université de recherche.
researchers.
Donc là, le projet il arrive à sa fin pour ce groupe d'étudiants pour cette année. Donc là, les étudiants vont transmettre les ruchers aux apiculteurs et on va mettre en test pendant le printemps, l'été. Et en fait, on va refaire des projets comme ça. Donc là, on va recommencer un projet avec un autre groupe d'étudiants. Parce qu'en fait, à travers ces projets, ils apprennent l'électronique, ils apprennent à créer un système embarqué complet. Ils vont mettre tous leurs résultats sur un GitHub
Also,
de
they
l'école.
have to put all the
Polytechnique Sorbonne.
results on a
Et
GitHub.
en fait, l'idée, c'est d'enrichir les connaissances qui pourront être analysées aussi par d'autres spécialités de l'école
And then at
pour
the
que ça
end,
devienne un projet en fait, de
the
recherche
beekeeper
participative avec
acquire
des
the
chercheurs,
materials
des étudiants, des apiculteurs.
to use it on their own beehive. So I'm finished now. I'm sorry it was a little bit longer than expected. I find up.
Thank you, Professor Yann, for your full fruitful presentation, and also your way make us more active and more involvement in your presentations, and also raise our expectations and expand our knowledge about different platforms and different tools of distance learning and e-learning. But now I call Hamid. Hamid, if you please, there are 2 or 3 persons raise their hands, and also questions in chat. Please, Hamid.
Yeah, thank you so much, Jan. First of all, I would like to say that your English is really perfect, fluent, and I didn't have any problem to understand that. Even a really nice also, yeah, accents, a combination with the French and English. Really, I enjoyed your presentation. Thank you so much for giving your really live practical experiences out of your classes. So let's see. Let's start with the questions from Khaled Tamizi. Please come and yeah, the micro is for you, Khaled.
Thank you very much for your nice presentation, Mr. Yann, and the effort that you really do it to connect your student. First of all, I was a graduate from Paris-Saclay, so we are neighbors.
Okay.
Yeah. First of all, I would like to ask if you use microchip microcontrollers, because I already taught to my student at my university, and I tried to use the software Proteus for simulation and MPLAB.
MPLAB, yeah. No, I don't use microchip microcontrollers. I have some colleagues that are using it, but for my course, I don't use microchip microcontrollers. I'm using, as I say, LPC 70X from NXP, and that was, and also I use some STM32 boards more in project, because I didn't show it. I didn't have to show it, but sorry, it's not here. The embed platform, this platform, one of the
can be used for STM.
Huh?
The embed, it can be used with STM to program.
Yes, but not with microchip, I think, okay. Because microchip, the thing is that embed, you can use it only with ARM based, because it's an initiative of ARM. You can only use it with ARM based microcontrollers, but there are a lot of chips. And I know that microchip by Atmel since 2 years, I think. And there are some Atmel boards that can be used, but not microchip. But it was a choice for me to don't use microchip, because I think that microchip was very famous 10 years ago with the PIC and etc. But today, the most used microcontrollers in the industry is more ARM-based, Cortex-M-based microcontrollers.
Yeah, for that reason, I'm trying to move up to STM32 board system, and I start to learn about it. So if you have some materials or something, I will appreciate it to share it with me, because I'm managing to the next semester to start almost with STM32 rather than using microchip microcontroller, because now it's the
I don't have a course specific on STM32, but I use it with embed, and with embed is very easy, because my course of microcontrollers is a mix of register programming, low-level programming, to understand how to program a peripherals, how to program and to understand how it works inside. But also, I'm using more and more the high-level programming with embed, because when you use embed, as you can see here, sorry.
Yeah, I use it before embed.
Oh, you use embed it also? You can program very easily. You don't need a lot of. But I don't really have materials specific on STM32. But I can share my materials about LPC 7068. It's a Cortex-M based processor, but it's in French.
Okay, I'll try to manage with it. Thank you very much.
You can send me
my email
message, and I can share with you, no problem. I can give you here my email also if you want to exchange more. And so tech. I put it in the chat.
Yeah, I will send you a message
Yeah.
to a mail to.
No problem.
Thank you very much.
But I'm using with embed. I'm using a board. This board. It's very common because it's very cheap. This one, Nucleo. It's cost 10 euros. And what's very good is that you have a microcontroller and a debugger on the board.
On the board.
Yeah, on the same
ST-Link.
board. Yeah, an ST-Link Ver2 on the same board for 10 euros. So it's very cheap. And we use most of the time, we use this board in the project. Also in the project, I show you about the beehive monitoring, we use this board. So I'm gonna send you also the link because it's a very useful board. It's very complete and it's very cheap.
Very cheap.
It's 10 euros. So it's when I see several years ago, when I was buying some boards for labs, it was cost around 200, 300 euros. The debugger also 300 euros. Now today, you can find some evaluation boards. It's much simpler, but for 10 euros. So it's a very big change these last 10 years.
So thank you so much for this case. So now Mira Salaima, if I'm right, yeah, please come and yeah, please ask your question.
Is my voice heard?
Yes.
Yes.
Okay, thank you, Mr. Hamad, and thank you, Yann, for sharing your methods that you have developed since the start of the pandemic. And I want to talk about the Palestine Polytechnic University experience in preparing exams through Moodle at the COVID-19 period. Many teachers here prepare quizzes through Google Classroom directly, and others prepare their quizzes through preparing question categories and banks through Moodle. And then the teacher set at Moodle to choose a random questions from question bank, where every student will have a different form of questions. But unfortunately, and despite that, we still suffer sometimes from students cheating in electronic exams. So do you have any suggestions to solve this problem in this subject? And thank you. Thank you very much.
Yeah. If I understand the question, is that they cheating? That means that they copy together?
Yes.
Yeah.
Yes.
Yeah. Yeah. I think it's also a little bit difficult, but the only solution that I find is to give a lot of questions in a short period, so they don't have a lot of time to communicate.
Yes, I do that. Yeah.
We do that also. We do that.
Yeah, and the other thing
still we suffer.
Yeah, and the other thing is that for example, in Moodle, in the test Moodle, I don't use Google Classroom, so I don't know this tool. But in the Moodle test tool, you can choose between sequential or I choose a methodology that they can now go back in the questions, because when you give
sequential navigation,
yeah, so they cannot come back.
Yes.
Yeah, that is also a good solution to avoid to limit the copy between each student, because when you can come back, because the questions are not in the same order, normally they cannot synchronize on the different questions.
Okay, thank you. I mean that you don't use any additional instrument or any additional program for solving this issue.
No, for my point, but I notice with my exams, when I see, because I know a little bit my students, I have some grades that correspond to the level of the students, because I can see in the labs and also in the question, and there are some students that I know since the year before. and I don't have a lot of copy problems.
Yeah.
But because so I don't search some other strategy, but it's sure I know that some other people use some ask to the students to put on the camera and on Zoom, and so they can see all students that are not speaking with others, but it's a little bit, I think, a little bit intrusive. So I don't use this kind of systems, but I know there are some colleagues at the university, they are using this kind of methods to ask to each student to open his camera and to see that he's not trying to...
We do here sometimes. Sometimes some of teachers they do this. Yes.
Yeah, I don't use it for the moment, but I think my grades are a little bit the same as the other years. So for me, it was correct. I don't have a lot of... I have some students with... it was sure better. The other thing, what I found better with the online test evaluation, that you can create more evaluation. And I try sometimes also to do, after each course, to do a little evaluation. Yeah. So to be sure that they follow the course. So they give a lot of little grades, but sometimes they are good, but the goal is that they learn, that they understand the topic. So it asks a little bit more work because we have to prepare the questions, and that can be sometimes a lot of work. But after that, you can be sure that they follow the course and that they understand the main goals, the main topics of the course.
Okay, thank you.
May I add something for Mira? If Hamid, I don't have a copy and paste from my students because I make that what look like what Yann said, that there is no time for them to speak with others, with each others, because the exam is in the fixed time. It is fit with the time. And also, sometimes I ask them to present their understanding by their languages in order to read what they understand. It is also unique answer, not it is not a common answer between students. This is also the second way. Sometimes I ask them to utilize this their answer or thinking their thoughts in a real situation related to their interest and their the different types of questions, and but also in the time. Till now, I don't have any copy paste answers from my students.
Yes.
Thank you.
Thank you.
Thank you.
So thank you. And now we
Jalal.
have a question from Engineer Jalal. Yeah, please.
Assalamu alaikum. First of all, I want to thank Yann for your presentation. And you, at the beginning of your presentation, through your experience, you said that you are not satisfied about the output of the students when you are focusing on lectures and knowledge and not on labs. Okay, what I want to ask is you are talking about how to develop new methods for students to create the lab or the workshop. What you present is about electrical and maybe computer engineering. I want to know how your colleague in mechanical engineering and in other fields of engineering can benefit from these methods, or do you have any methods, any tools regarding practical mechanical engineering and civil engineering? This is the first question. The second question, regarding your students, when you are going to evaluate the practical skills, such as fixing, such as assembling some system and installation, what are you doing regarding this issue?
Okay, thank you for your question. So the first question, I don't know if I have some answer, a good answer for you, because I don't really. I know that some colleagues are also using some using some projects-based learning and problem-based learning, but I can give you more details about mechanical engineering, for example. But I was thinking you, but perhaps I know that they are using a lot some how do you say these tools, CATIA and also SolidWorks, and they also design some mechanical pieces, and they do some project with them to but I'm not more I don't know more about this, so I cannot give you more details about it. And the second part of the question is for the evaluation. So I ask to make most of the time they have to make a report where they explain all for a short project, for 20 hours project, they have to make a report. And also sometimes I ask to make an oral presentation, and that is also very important, because in the industry they need to present them work, and it's also one of the knowledge and the skills that they have to develop, is to present them work, make oral presentation or writing report. That is very important for the skills that they have to develop for the industry. And also for more long project, for example, the beehive monitoring project that I show you, it's a project on a semester. We make interval reviews. So we call it project reviews, like in the industry, and they have some goals to achieve for each review. And we make some short it's a group project. There are by 4 or 5 students, and they have to explain what they achieve during for each month. For example, we do a review of the project, and they have to explain what they do during this period and to achieve some goals for each part. So that was the manner that we, and also perhaps one thing that we asked them, I can show you, I can share my screen. We ask since a couple of years, 3 or 4 years, in place to make a report and give us a report, and that is being on our computer. We ask to make an article on a sharing. In place to make a report, we asked to make an article here. For example, I show you one of the article of my students. Here, for example, ST Connect. They have to write an article on this kind of site. It's a knowledge sharing site. So they have to, and we give a grade also for this. That is one example. So they talk about the project, they present each piece, they give also the schematic. So this one is the code, etc., and also the story of the project. That are project of my students. I can share with you if you want.
Yes. Yes, if you please.
And so also it's nice for them because they have something to show to what they did during their studying. So kind of what we call in French a portfolio. So they can also say, during my studies, I did this project. Look, you can see it here. So with the story, with all the code they developed, the different steps, and more, we ask them to make this kind of work also in English. So that gives them with the schematic of the and extras. But it's right. It's really focused on my field, on electronic embedded systems. So, and I think it's different in mechanical engineering, but I'm not close enough with my colleagues of mechanical engineering to know what they are using for tools and etc. So it's a little bit too difficult to me to respond to your question. Here, there's another beehive I can share. That this one is also one project of my students. And so also they can sometimes have some interaction with other people's. So I share some of this project. There's this one is also AnyTrack. It was a tracker for animals. So I asked them to make and I grade it. So I grade this report in place to give me a report. I asked to do an article on this kind of site, and I grade it.